This video provides practical information and training in construction techniques using the EcoBlock insulating concrete forming system. It is intended for experienced contractors and installers who are already well-versed in common construction techniques, as well as being familiar with the specific requirements of their own local building regulations and codes. This program was produced at Hands-On EcoBlock Workshops, sponsored by Terry Tool Concrete Incorporated and Superior Building Systems Incorporated in Fresno, California, as well as at other distributor workshops. It covers the construction of a 2-story residential building, as well as commercial block and tilt-up applications. EcoBlock is a patented ICF system that, for the first time, enables builders to use a single field-engineered ICF line for residential walls, commercial walls, footers, grade beams, insulated floors, and tilt-up applications. The EcoBlock system consists of flat side panels, corner panels, brick ledge panels, connectors, 45-degree panel connectors and 90-degree panel connectors. With these components, forms of any size, shape, and thickness can be built. For efficient handling and storage, EcoBlock is shipped unassembled in bundles. Products are wrapped in color-coded UV protective bags that can be safely stored outside. But it is best if the bundles are not kept in direct contact with the ground for long periods of time. All bundles are lightweight and easily handled by one person. There are 2 EcoBlock side panels. The standard panel is 16 inches high, 48 inches long, and 2.5 inches thick. The commercial panel is 24 inches high, 48 inches long, and 2 inches thick. The same EcoBlock side panels are used no matter what concrete core thickness is required. The top and bottom edges lock into one another for a tight course-to-course connection. EcoBlock's unique latching webs are molded into the side panels every 8 inches. They are designed to serve 4 functions. They add strength to the form. On the inside of the panel, the latching attachment points provide a fast, secure point for placing the system's connectors. The dual lock design enables connectors to be placed in either direction. The tie tabs are a strong attachment point for zip ties or tie wire. The outside face of the web, recessed just below the surface of the panel, provides a secure attachment area for mounting finishing materials, fixtures, and pre-placement form support. The grooves on the inner part of the side panels facilitate concrete consolidation during placement. The lines on the outside of the panels are in 1-inch increments, a handy reference for measuring and cutting. The deeper grooves extending from the top edge mark the center point of each web. EcoBlock latching connectors come in standard sizes to make forms with 4-inch, 6-inch, 8-inch, and 10-inch concrete cores. The cutouts in the top edges of the connectors are designed to lock onto number 4 and number 5 rebar without additional tying. 45-degree panel connectors and 90-degree panel connectors are manufactured for both the standard and commercial panel systems. They are a new, efficient way to reduce time-consuming wood bracing. Splice connectors are used to join standard connectors together to make thicker forms, 12 inches, 16 inches, up to 24 inches wide. Tie anchors, often called Texas tees by seasoned eco crews, are tie points for zip ties or wire that are clipped directly to the webs. They facilitate the construction of forms with special cuts or shapes and help minimize the need for additional bracing. 90-degree corner blocks for the 16-inch standard panel system are manufactured to build forms with 4-inch, 6-inch, or 8-inch concrete core thicknesses. 3 right-hand and 3 left-hand forms are packaged in each bundle. To build forms with cores larger than 8 inches in the 16-inch standard panel system, the outside panel of the 4-inch or 6-inch form is used, with the interior panel being trimmed to fit on the job. In the 24-inch commercial panel system, 90-degree corner blocks are manufactured to build forms with 6-inch or 8-inch concrete core thicknesses. For other form sizes, Left and right outside 90-degree corner panels are bundled without matching inside panels. The inside panels are fabricated on site using a 90-degree corner connector. EcoBlock's exclusive brick ledge panels enable walls to be formed with a monolithic concrete ledge. This ledge is used to support a brick fascia, floor trusses, or other structural elements requiring the strength of solid concrete support. Brick ledge rail is part of the brick ledge system and is used to support standard EcoBlock forms above the ledge course. Experienced contractors have found that they can efficiently build even the most demanding EcoBlock projects with a simple set of tools and materials. Form construction requires a folding handsaw, level, hammer, tape measure, chalk line, wire tying tool, cutters for zip ties, cordless drill, screw gun, rebar bender cutter, and a skill saw. A table saw can also be very useful. The plumber and electrician will want to have an electric chainsaw with depth gauge or stop, or a hot knife with ICF attachments, or a router for cutting grooves and rectangles in the foam. The list of supplies includes strapping tape or perforated plumber's strapping, rebar tie wires, zip ties, low expansion foam adhesive, duct tape, PVC pipe for utility pass-throughs, and dimensional lumber for bracing and support like 2x4s and 1x4s. There is an increasing variety of specialized supplies that builders are finding efficient and cost-effective. In this course, you will see 2 different systems for mounting floor ledger bolts. You should check with your distributor from time to time to keep up with new developments and methods. The fastest way to build up forms is to use the first block as a jig and assemble the other blocks on top of it. Connectors snap into place on the web's locking tabs. When you hear the click, you know it's secure. On standard panels, 2 rows of connectors are generally used, except on the bottom course. The first row is placed along the second from the bottom set of locking tabs. The second row of connectors is placed along the top row of locking tabs. It's a good practice to double-check the block by looking down each row of connectors to make sure they're all snapped into place. Because the bottom of the form experiences the greatest pressure when placing concrete, it is a good practice to use 3 rows of connectors on the first course of standard forms. The 3 connectors are placed on the bottom, middle, and top locking tabs. The structural integrity of EcoBlock enables it to be cut to almost any special dimensions the plans might require. For most vertical cuts, a folding handsaw is the fastest and most convenient tool to use. The grooves on the outside of the forms are ready-made cutting guides in 1-inch increments. Looking at the upper edge of the block, you'll find that if your vertical cuts are on the groove, the course-to-course locks will automatically line up. Staying on the groove also means that you will not be cutting through one of the webs. So to keep it simple, most contractors choose to adjust the plan slightly when required to make sure they're cutting on 1-inch increments. It's also a good idea to make your vertical cuts just a hair short. This keeps you from having to wedge a form into place. Forcing in a form that's too tight chances throwing other blocks out of alignment, distorting the wall. For speed, lateral cuts are usually made with a power saw, although it's certainly not required. If you're cutting just a few blocks, using a 1x4 as a straight edge and a skill saw is the common way to go. For long runs, a light table saw is usually the tool of choice. The wall is usually planned such that the short block are on the top course. When this is the case, measure from the bottom of the block to preserve the locking groove. If, for some reason, additional courses will be laid on top of a laterally cut block, measure from the top to preserve the locking edge. Notch the bottom to fit snugly onto the locking edge of the course below. Use a table saw with a 3/4-inch dado blade, or make 2 cuts with a standard blade and remove the foam by hand. Some builders use a router and jig with a 3/4-inch channel blade. Notching enables you to make 2 half-high blocks from a full block with no waste. There are 3 important things to remember when planning your cuts. Make sure that the webs line up vertically in the wall. This is important to maintain the optimum flow of concrete into the cavity once the form is complete and keeps the attachment surfaces on the finished wall in line. Think 2x2. A cut eco-block form will maintain its structural integrity without additional bracing if it is at least 2 connectors high and 2 webs long. If you go under 2x2, some reinforcement will be required before placing concrete. If a cut is going to leave more than 8 inches between adjacent webs when the form is in place, you'll need to reinforce the seam. EcoBuck from ICF Support is a new, efficient alternative to traditional wood buck construction. This modular extruded PVC system has several advantages. It is lightweight, requires minimal bracing, eliminates air infiltration, resists insects, is waterproof, and will not warp. There are 3 components to the system. Standard end rails are 2.5 inches wide, sized to work with the standard panel, and are bundled in 8-foot lengths for convenient handling. Like dimensional lumber, they are 1.5 inches thick, so they can be cut with ordinary tools. The face is textured to facilitate the adhesion of surface coatings and finishes. Filler pieces are manufactured in 4-inch, 6-inch, and 8-inch sizes and are also 8 feet long. A flange extends into the form cavity to hold the buck and block in perfect alignment. The notch in the center of the filler piece enables webs from scrap block or Texas tees to be slid into position for securing the completed buck to the form as it is built. Reusable corner buck braces are temporarily installed to hold the buck square until concrete is placed and set. The buck should be built such that its inside dimensions match the rough opening required for the window or door. Bucks may have to support hundreds of pounds of wet concrete during placement. You should size the lintel to overlap the tops of the jambs. The sill is built to the exact rough opening width. This helps distribute the pressure of the wet concrete. To assemble EcoBuck to the proper width, slide the end rails onto the filler piece. 2 filler pieces will slide together in the same way. By combining different sized filler pieces, perfectly fitting bucks can be built for any concrete core thickness, from 4 inches on up, in 2-inch increments. By staggering the joints when assembling end rails and filler pieces, EcoBuck can be built to virtually any length. This is the technique you would use for garage door openings or any other large buck. By utilizing smaller pieces in the same way, scrap is almost eliminated. When slid together, the end rails and filler pieces are cut in one unit like dimensional lumber. Because you must leave gaps in the sill's filler piece for placing concrete, it's built differently. Cut the end rails to the full dimension of the rough opening. Then, cut the filler piece in smaller pieces. Size them to leave about a 6-inch gap approximately every 18 inches along the sill. Once the EcoBuck is cut to size, slide the pieces apart and reassemble them using ordinary PVC cement. The PVC cement locks the pieces together in a rigid unit. Keep in mind that the PVC cement sets fairly quickly. Remove any cutting burrs and check to see that the channels are clean before applying the cement. Once the sill, jamb, and headers are built, set them aside until the EcoBuck form is ready for the first buck piece to be set. EcoBuck is installed as the wall is built. Before you start setting block, make sure that the slab or footing is clean and smooth. Any high spots or low spots are going to show up in the walls. You'll see how to correct for out-of-level problems in a few minutes after the second course is finished. The slab or footer needs to be within a 1/4 inch of dead level to avoid correction work. If you're going to be working on a step footer, it's a good idea to have it step in 16-inch increments. That keeps you from having to cut partial height forms to follow the contour. Good walls start with careful measurements and clean lines to mark the outside or inside of the form. To keep the lines from being scuffed while working or blurred by water, some builders give them a light coat of fast-drying lacquer. After making the chalk lines, it's also a good practice to mark the locations of windows and doors. These will serve as reminders when you're laying out the wall. Although it is not required, some builders cut PVC collars to go around the dowels. When the wall is finished and the vertical rebar is being inserted from the top of the form, these collars capture the vertical rebar and hold it close to the dowel. Before setting block, fix the door bucks in place. Be sure they're plumb and set the kickers in a way that they can be adjusted later on if the bucks go out of plumb. To keep the work area clear, it's a good idea for the kickers to be run to the outside. Start placing forms by setting the corner blocks first. Put a right-hand corner at one end of the wall and a left-hand corner at the other. Then, if possible, work inward with straight forms such that the two meet at a door buck or under a window. When there are no openings, stack block from each end to the center of the wall. Hold off cutting the final block until everything is on the mark and tight. Remember, this first course will be the model on which all other courses are built. If something is off with the first course, you can be sure it won't get better as you stack higher. Zip tie or wire together the top connectors of all adjacent blocks, one to the next, to pull them tight and in line. Builders often fit an EcoBlock straight panel over each first course joint to be sure. Double check your marks. Now measure and cut the final block. Remember to keep it a touch short so you don't push everything off the mark by wedging it in place. If the cut leaves more than 8 inches between the webs, either cut a piece of 1x4 and screw it into the adjacent webs for reinforcement, or mark the joint for reinforcing at a later time. If the plans call for horizontal rebar, put it in next. Fit the corner pieces first, and then continue with the straight runs. Number 4 and number 5 rebar will snap into the notches on the connectors. There are many schools of thought as to how close or far apart pieces of rebar should be and how much they should overlap. Go by the methods you're accustomed to, following the building codes for your area and the engineered plans for the building. Begin the second course by starting at the corners again. To offset the joints, put left-hand corner blocks on top of the first course's right-hand corner blocks and right-hand corners on top of the first course's left-hand corners. Again, bring the two sides together at a door buck or under a window. If there are no openings, work toward the center, just like on the first course. Before measuring for the cut, zip tie or wire the top connectors of each corner block to the straight block next to it. Unlike the first course, there is no need to hold all the blocks together with zip ties or wire. The second course is held tight by locking into the first. That's part of EcoBlock's design. Cut the final block and fit it in place. Make sure that the vertical joint is offset at least 4 to 8 inches from the joint on the course below. At this point, you can see the course-to-course pattern. Except for special cuts required for wall openings, the first course is the model for the third, fifth, and so on. The second course is the model for the fourth, sixth, and so on. By reversing the corner blocks on each course, most vertical joints are automatically staggered 16 inches. The second course is also an excellent time to check the level of the walls. Level is checked by either shooting it with a laser or using a bubble level and pulling a string tight from corner to corner. If there is a high spot along a wall, while someone presses down with moderate pressure, carve out a bit of the bottom of the first course block to make up for the high spot in the footer or slab. If there's a dip in the form, build it up with shims from scrap EcoBlock. Once you're satisfied with the level of the forms, set the second course rebar if the engineering plan calls for it. Note how the rebar is staggered front to back down successive courses in a finished form. This keeps the vertical rebar near the center of the concrete cavity. EcoBuck is installed as the wall is built. Before setting the sill, make sure that the supporting blocks are cut to the proper height, allowing for the overall width of the buck. Webs from scrap panels slid into the notch on the filler piece are ideal for securing EcoBuck to the form. Using webs ensures that the buck will be fixed solidly onto the concrete core. When there is insufficient clearance or depth for webs, Texas tees may be used. Make sure to pull the zip ties snug and trim off the excess. Tie the sill to additional connectors installed upside down, 6 inches or more down the webs. The connectors are installed upside down so the pressure of the zip ties pulls them onto the web's lug, not against the locking tab. When the next course is set up, set the jambs. Here a Texas tee is being used to hold the jamb in place against the block as the wall is built up. Tying off 2 connectors back from the opening helps distribute the pressure. As additional courses are set, webs are slid into the EcoBuck to secure it into the form, again tying to the second connector back. The dimensions of this particular buck are such that the block fitting over the lintel must be cut too close to the connectors for the buck's flange to seat properly. When this is the case, mark the flange and cut it to fit around the connectors. The lintel piece of the EcoBuck is tied to the steel reinforcement installed above the opening. The reusable galvanized steel corner buck braces are installed last to hold the EcoBuck square until the concrete is placed and set. If the end cuts on the jambs are perfectly square and the buck is secure in the form, as few as 4 corner buck braces can be used, 2 on opposite inside corners and 2 on opposite outside corners. To be safe, some builders use 2 additional corner buck braces to secure the inside and outside of window bucks at the top corners. Door openings require corner buck braces only between the jambs and the lintel. Before completing the courses directly below and above bucks, go back and fix rebar dowels at 45-degree angles to each corner. The dowels should be 36 inches to 48 inches long and positioned so they extend an equal amount above and below the corner. You can tie them in place to either the horizontal rebar or a connector. After completing the third course, it's time to install the EcoBlock wall alignment system. Outside of providing a safe working platform for setting the upper courses, the wall alignment system is the primary tool for ensuring that the forms are straight and plumb. The uprights are set approximately every 6 feet along the wall, starting about 3 feet from the corner. As you are considering where to place the uprights, think about where you will want to be standing while pumping the concrete, as well as what surface is going to provide the wall alignment system with the surest footing. The EcoBlock wall alignment system from ICF Support is a new third-generation design based on the practical requirements of field use. It is built from hot-dipped galvanized steel and is OSHA and CSA compliant. There are 4 major components: the upright rail or strongback, the scaffolding bracket, the guardrail bracket, and the kicker. The upright rail has a telescoping extension that enables the unit to be built in configurations from 8 feet to 11 feet 6 inches tall, enough for 12-foot walls. The safest and easiest way to set up the wall alignment system is to mount the scaffolding bracket while the unit is on the ground. Stand the unit in place and set the foot of the upright, aligning it to the inside chalk line made when laying out the form. The foot is usually set with either nails or tapcons. Then screw the upright into the webs. It should be attached to each block. Screws should be placed near the middle of the slot, allowing the form to settle a little bit. Screws should be set snug, but not tight. Then set the kicker, making sure that the upright is roughly plumb and that the turnbuckle is in the middle of its adjustment range. The kicker's foot is fixed in place with either nails or tapcons on concrete or with stakes on soil. Keep in mind that if the kicker moves, your wall moves out of plumb. On soft soil, set a 2x12 first, to help distribute the weight and give the foot a sure fixing point. Finish assembling the frame by setting and pinning the baluster, then placing the walk boards. The balusters have brackets for 2x4 handrails. If the walk boards are 8 feet or more off the ground, OSHA requires the use of handrails and toe boards. With the system complete, go back around and adjust the turnbuckles so that the uprights are plumb. For low forms like foundations and grade beams, lumber bracing is generally used to align the form, but the working principles are the same as for the full wall alignment system. A vertical 2x4 is screwed to the webs about every 6 feet, starting near the corner. The base of the vertical is then held solidly to the line. It can be driven into the soil, attached to the footer, or braced against the side of the ditch. With the vertical support being held plumb, a diagonal leg is set to hold it in place. Keep in mind that, again, plumb may need to be reset. Using screws instead of nails for attaching the supporting leg will make adjustment easier and more precise. The top course is built up in the same manner as the preceding courses. After the horizontal rebar, if required, is set, it's time to place the vertical rebar. The vertical rebar is generally thought of as an extension of the dowels set in the slab or footer. If you're using PVC collars, you'll want to set the vertical rebar in the collar next to the dowel. If this is the finish course, cut the vertical rebar so that it will be below the top of the wall or the bottom of the sill. If you will be setting another story of EcoBlock, make the cuts long enough that the required overlap remains above the wall. When inserting vertical rebar, make sure it slides between the horizontal runs. If you pull it up 3/4 of an inch or so from the bottom before tying it off, the weight of the rebar will help hold the form in place. Floor ledger is installed by either cutting the holes through the foam and aligning the bolts by hand, or by employing one of the commercially available ICF ledger systems. With either method, start by chalking lines on the wall to mark the location of the ledger board. Without a commercial system, you'll next cut out rectangles of foam to provide the ledger with the maximum amount of direct support from the concrete core. For a 2x8 ledger, this would be about a 6x6 hole. For a 2x10 ledger, it would be a 6x8 hole. Note how the bottom of the holes are angled downward. This helps ensure that they will fill evenly with concrete. Now, drill the holes in the ledger board and mount it in place by screwing it to the webs. Insert the anchor bolts, then hold them in place with nuts and washers. Some builders attach the anchor bolts to the ledger on the ground so it can be set in place as a complete assembly. Since the ledger is in direct contact with the concrete, it will need to be pressure-treated lumber or protected by a waterproofing membrane. This commercial ICF ledger mounting system uses plastic inserts that screw into the block. Holes are cut with a saw. The inserts are mounted in the holes with a special tool. This system makes its own marks for cutting out the foam, and being clear allows for visual inspection during placement. The bracket is held in place and tapped to mark the foam for cutting. The foam is then cut out. The bracket is held in place by its corner lugs and zip-tied tightly to short pieces of rebar on the inside of the block. Because both of these commercial systems keep the concrete from being in direct contact with the lumber, pressure-treated stock or waterproofing is not required. Any wires or pipe that will be passing through the wall should have a sleeve inserted through the form at the appropriate location. Use PVC pipe cut to the width of the wall and just a bit larger in diameter than whatever is supposed to go through it. Cut through the foam and set the sleeve in place. If the sleeve feels loose, use adhesive foam to glue it in position. Some builders will mount interior stud walls directly to the surface of the form using anchor bolts set in the core. If that's what you plan to do, mark the location of each interior wall and set the anchor bolts through the foam. If brick ties need to be mounted, they can be screwed directly to the webs, or slip through cuts in the foam to be held in place by the concrete core. Special joist hangers that slip through the foam are also available. Now it's time for the final work on the form. For strength and stability, run 2 strips of strapping tape around each corner block, going from the first full block on one side to the first full block on the other. Look over the form carefully for potential trouble spots and things that might have been missed during construction. Check all cut block to make sure any required reinforcement is in place. Horizontal bracing should be used when you have openings close to the corners. Cross tie when bucks are closer than 2 blocks apart. Fill any gaps you find with foam. If another story of eco-block is to be built on the walls, cover the top edges of the form with tape to protect the tongues from concrete. Alternatively, some builders use 4 to 6 foot lengths of gutter to cover the top edge, moving it along during placement. Plumb and straighten the walls. It is important to keep the walls plumb before, during, and after concrete placement. The easiest way to check plumb on a finished wall is to stretch a string just a bit off the top edge. While one person measures the distance between the string and the wall, another can adjust the turnbuckles on the wall alignment system. Finally, pick up the job site. A clean job is safer and easier to work in. On the day before placement, reserve some time to double-check the form. As the saying goes, foam is easy to correct, concrete is hard. Go over the project step by step to make sure you've covered the bases. Does the layout match the plans? Are the walls plumb? Are the walls square? Is the top of the wall level? Are all bucks in place, plumb and square? Is each buck securely connected to the forms? Are all bucks braced against racking? Are all cuts and weak spots reinforced? Are all anchor bolts for interior walls in place? Is the top course of horizontal rebar in place? Are all vertical bars in position and secured? Is the ledger in place and securely fastened? Have you planned out where to position anchor bolts or straps along the top of the wall? Do you have enough anchor bolts or straps on hand? Do you have plywood and scrap 1x4s on hand to screw over weak spots that might appear? Have you received all required inspections and approvals? Is the job site clear for the concrete truck and any pumping equipment and crew on the ground? Is the concrete ordered? Is the pump ordered? Once you can say yes to all these questions, you're ready to go. If you're working at ground level on a foundation or grade beam, placing concrete out of the chute is practical. If you're working above grade, pumping equipment is required. Placing the concrete with a pump is not difficult, but it helps to have some experience. If no one on the crew is experienced, it's a good idea to hire someone who is for the first couple of jobs. The wet concrete exerts a great deal of pressure on the bottom of the form. EcoBlock is designed to handle it, but you need to avoid doing things that will increase pressures to dangerous levels. The first step in controlling pressure is to work around the form in 4-foot lifts. By the time the first lift is completed, the placed concrete has usually cured enough that the second lift does not cause a dangerous increase in pressure at the bottom of the wall. Instead, the pressure is now concentrated at the bottom of the second lift. Outside of lift, the force of falling concrete, excessive vibration, and water added to the mix can increase pressures by 1.5 times or more. To control the pressure of falling concrete, use an S-bend on the boom and a 2-inch line. When working from a chute, break the fall of the concrete with a shovel. Many builders forego the use of vibrators in favor of hand compaction with wood blocks or using a block mounted to the end of a reciprocating saw. They must remember to work only over the webs. When a vibrator is used with EcoBlock, the recommended size is 3/4 of an inch, and never use a vibrator larger than 1 inch. If you need to add water to the concrete mix, check with the batch plant before proceeding. Because 4-inch wall cavities fill so fast, the pressure on them will actually be higher than with thicker walls. When placing 4-inch forms, remember to hold back on the concrete flow accordingly. Start placing the concrete by filling the area underneath the window bucks. After the window bucks are placed, move to one end of the wall, about 4 feet from the corner. Do not place directly into a corner. Instead, let the concrete flow into it. Once the concrete is at the desired level, move about 2 feet down the wall and bring that section up to be even with it. Continue down the wall, skipping over the bucks. Stop about 4 feet short of the next corner, again letting the concrete flow into it. Work the forms in a consistent direction. Don't skip around. Finish the first lift completely, then go on to the second. Keep 1 or 2 people on the ground consolidating concrete and watching for trouble areas. The concrete should be consolidated continuously as it is placed, working every foot down the wall with each lift. Check the string line at the top of the form, adjusting the wall alignment system turnbuckles to keep the forms perfectly plumb as you work. Immediately after placement, check the string line again and check your vertical alignment. Make any last adjustments before calling it a day. After the concrete has set for 24 hours, you can remove the straps from the bucks. The wall alignment system and bracing should remain in place according to your local building requirements. With the EcoBlock connector system, building wide forms is not very different from standard size construction. Because standard corners are not manufactured in sizes over 8 inches, the inner panels must be made up on the job for wide forms. By using zip ties and 90-degree corner connectors, wide forms can often be built without additional wood bracing. Make sure that the chalk lines marking the inside and outside of the wall are clear. Begin by placing an outside corner panel on the chalk line marking the outside of the wall. Set a straight panel on the inside chalk line. You can automatically line up the webs of the inside and outside panels by setting a couple of connectors. They don't have to be locked in because we'll be removing them to cut the panel. Mark the inside panel for the cut where the chalk lines cross. Next, attach a full panel to the opposite leg of the outside corner by looping a zip tie around the connector lugs on the end webs of each panel. Remove the first inside panel that's marked for its cut and set the other inside panel temporarily in place. Again, setting a couple of connectors will hold the webs in alignment. Starting where the inside chalk lines cross, go over 2.5 inches. That's 2 1/2 bars, and mark for the cut. This mark is shifted over so the panels overlap the proper amount at the corner. Next, slip the connectors off and cut both panels. To allow for the space that will be taken up by the 90-degree corner connector, make each cut just short of the line. Set the cut inside panels in place and snap in the connectors. Notice how the first inside panel runs long. That's okay. We'll make up for that on the next block. With the connectors in place, the corner lines up, ready for the corner connector. Push the corner connector into place. Attach Texas T's in place of connectors on the outside panel where there is no matching web on the inside panel. Use the same number of Texas T's as you would connectors. Zip tie from the Texas T's to the base of the opposite connectors. No further lumber bracing or banding is required. Similar combinations of corner connectors, Texas T's, and zip ties are the key techniques to most special fabrication with EcoBlock. 90-degree EcoBlock commercial corners are manufactured in sets with both inner and outer panels to build forms with 6-inch or 8-inch concrete cores. These corners are assembled like straight block. For other form sizes, left and right outside 90-degree corner panels are bundled without matching inside panels. The inside panels are fabricated on site using the 90-degree corner connector. When building a form size that requires the inner panels to be fabricated, begin by snapping chalk lines marking the outside and inside faces of the EcoBlock form. The panels for the inside of the form may be pre-cut according to this table. All of these counts are measured from the web that will be closest to the inside corner on each panel. The number of bars refers to the number of 1-inch bars past the web. A 0 refers to the line marking the center of the web. Set the 90-degree outside commercial corner panel on the outside line. Then, set a long panel next to the short leg of the commercial corner panel. Set in a couple of scrap pieces of panel. Line up the connectors and see how they'll match at the inside corner. Remember that the short panel should never be smaller than 2 webs wide. Next, count out the cuts to make the inside panels. In this example, we're building a 10-inch core. That means the cut on the left panel will fall at 0 bars directly on the web. Instead of trying to cut through the web, it's easiest to simply lay the block over an edge, break it, and pull the web out. Clean the cut up with a saw if necessary. On the inside pieces, we count over 6 bars and cut. Set the panels in place. Set the connectors. Slide in the 90-degree corner bracket. Next, tie the corner block to straight blocks on each side using zip ties. Zip ties are used on the inside of the form to reinforce the corner. Slip the zip tie through the slot in the outside corner web and then through both webs that are closest to the inside corner. You'll do this twice. On corners of core thickness of 8 inches or larger, there will be 1 web on the exterior panel that has no mate on the interior panel. On this web, attach 3 Texas T's in the same position as you would connectors. Tie the Texas T's to the connector on the opposite leg of the wall. On 2 bar cut pieces, the webs will fall too close to the 90-degree corner bracket for a good fit. The solution is to cut 1/2 inch off the corner bracket on the 2 bar side. This can be done with a utility knife or saw. It's a good idea to temporarily hold the first course corner tight with 1x4 banding while the form is being built. This helps hold the form in place for succeeding courses. No further banding is required. As the form is built up, alternate the layout of the inside panels. If you use 0-bar 6-bar cuts on the first course, use 6-bar 0-bar cuts on the second course. Remember to alternate the outside corner panels between left and right as you add courses and to keep the webs in vertical alignment. To efficiently build a solid monolithic T-wall, the T-wall tie-in courses must be started as the main wall is built. Begin by checking where the edges of the T-wall core will fall on the wall behind it. Be sure that one of the edges will not fall directly on a web. If it does, adjust the position of the T-wall slightly from side to side. With block position for the T-wall, mark where the core of the T-wall meets the block on the form behind it. Cut out the marked section of the back wall's block and reset it into place. Reset the block for the T-wall. Again, EcoBlock's 90-degree corner connector can be used to replace time-consuming inside corner lumber bracing. If there is an available web on the back wall, use Texas T's and zip ties to attach the web of the back wall block to the connectors on the T-wall block. Make the ties snug, but do not place more strain than necessary on the connectors. If the T-wall falls between webs, zip tie around the corner to the nearest connectors. If the cut falls within 4 inches of the webs on both the T-wall and the back wall, no corner connector is required. By utilizing the 90-degree corner connector with these zip tie techniques, no additional bracing or banding is required. When placing rebar, remember to alternate the direction of the corner pieces tying into the main wall as you add courses. If the rebar points left on one course, it should point right on the next. The 45-degree corner connectors eliminate the need for any wood bracing or strapping when making 45-degree corner forms. Start with a block that is built without the end row of connectors. Set it on the lines chalked onto the slab. Position the block so that the outside corner web is 2 bars from the corner. Mark the cut. You can save some time cutting by setting the block for the next course on top, transferring the marks, and cutting both blocks at once. When setting the second block, remember to line up the webs and allow for proper offset. Temporarily assemble the block for the other side with just a couple connectors to align the webs. Set it on the chalk lines and line it up just like the other side, with the outside corner web 2 bars from the corner. Mark and make the cuts. Slide the 45-degree corner connector onto the fully assembled block. Take the connectors out of the block for the other side and slide the panels in individually. The 45-degree corner connector fits tightly, so trying to insert fully assembled block on both sides can be difficult. Once the panels are in place, latch in the connectors. Mount Texas T's on the empty webs on the outside of the corner. 2 T's per web will usually do the job. Lock the front of the blocks in place by running zip ties from the Texas T's to the adjacent connectors. As a flexible alternative to attaching frame walls by setting bolts in the core, many builders wait until the concrete is placed and cured, attaching frame walls either to the surface of the foam or directly to the hardened concrete core. To attach a frame wall directly to the concrete core, the stud's location is marked, then the foam is cut out and removed. The stud is then set into place and drilled for tapcons. Because the lumber is in direct contact with the concrete, pressure-treated stock must be used. Surface mounting is usually done with expansion bolts running through both the stud and foam into the core. A stud is set into place and the holes are drilled for the expansion bolts. Then the expansion bolts are set and tightened. Both of these methods work well, but how each is used depends upon builder preference and is often guided by how much weight the frame wall is intended to support. EcoBlock's exclusive brick ledge enables builders to use the strength of monolithic concrete to support brick fascia, beams, and flooring systems. Brick ledge is completely integrated into the EcoBlock family of products and is built up in the standard way using the standard connector system. When planning brick ledge work, remember to allow for the additional rebar required within the block itself and for the stirrups that tie the core to the ledge. Because brick ledge can be used on the inside, outside, or on both sides of the form, corners must be made on the job. This will guide you through making a corner with the brick ledge on the outside of the form. The other configurations are adaptations of the same procedures. To start making a mitered brick ledge corner, notch the tongue of the corner block below so the brick ledge panel sits flat. Next, set the brick ledge panel in place for marking. Position it so that the end overlaps the seam in the corner block below by 8 inches. This ensures that the webs will line up vertically in the finished wall and provides for proper overlap. With the panel positioned, mark the brick ledge next to the outside of the corner for the bottom of the miter cut. Count over 5 inches and mark the top edge of the panel for the top of the miter cut. Draw out the cut on the face of the panel. Extend the mark you made on the top edge straight down the flat face of the panel, making that part of the miter cut vertical. Connect the end of that line to the mark on the bottom of the panel. Using a tri-square, mark the bottom edge for the 45-degree angle. Start the miter cut at the bottom of the brick ledge. The panel is more stable this way. It also helps if you set the panel on a soft surface like dirt or grass. This is a compound miter, so remember to hold the 45 all the way through the cut. When you get to the web, cut with light pressure on the saw and rapid strokes. If the saw hangs too much on the web, the foam may crack. When both brick ledge panels are cut, hold them together, square, to check the cut for a good close fit. If the miter is too shallow, cut away more of the foam. If it is too deep, you can use shims from scrap material to build back the edges. Even though the inside panel is straight, we'll follow most of the same steps to mark and cut it. Notch the tongue of the corner block on the course below so the panel will sit flat. Position the end 8 inches from the seam. Mark for the cut on the inside of the corner block. Since this is a straight side, the cut is vertical, straight down the panel. Build up both halves of the block, just like when making a 45-degree corner, and set them together. Cut a notch in the inside tongues so that the corner block on the next course will fit on top. The two halves of the corner are held together using zip ties. On the inner part of the corner, they go from connector to web. On the outside, they tie the two connectors together. Using a 90-degree corner connector on the inside of the brick ledge corner will ensure a tight seam and eliminate the need for additional lumber bracing on the inside of the form. The work on the inside of the form is finished by inserting the brick ledge rail in the standard way. The outside of the corner gets reinforced with strapping tape. If you see any gaps in the cuts, fill them with urethane foam. As a flexible alternative to attaching frame walls by setting bolts in the core, many builders wait until the concrete is placed and cured, attaching frame walls either to the surface of the foam or directly to the hardened concrete core. To attach a frame wall directly to the concrete core, the stud's location is marked, then the foam is cut out and removed. The stud is then set into place and drilled for tapcons. Because the lumber is in direct contact with the concrete, pressure-treated stock must be used. Surface mounting is usually done with expansion bolts running through both the stud and foam into the core. A stud is set into place and the holes are drilled for the expansion bolts. Then the expansion bolts are set and tightened. Both of these methods work well, but how each is used depends upon builder preference and is often guided by how much weight the frame wall is intended to support. Plumbing and electrical installation is very straightforward with EcoBlock construction. After some practice, most contractors find it as easy or easier than traditional lumber construction. EcoBlock's insulating foam is 2.5 inches thick. Most work can be completely recessed into the wall. The foam can be cut with a router, an electric chainsaw with depth gauge or stop, or a hot knife with ICF attachments. Because of the high-density plastic webs, it is easier to make long horizontal cuts with a router or electric chainsaw. After making the cut, wiring can be pushed right into the slot. It can be held in place with either spot glue or urethane foam. Conduit and piping require channels to be cut and the foam removed. Cutouts for electrical boxes are most easily made with a router or hot knife. After the foam is removed, boxes can be set with anchors and screws or glued into place. 2-inch PVC lines and fittings can be completely recessed into the foam. Larger sizes will require boxing out the wall. While larger sizes can be run through the core before the concrete is placed, that might create a serious weak spot. Check with the engineer before running any plumbing up the cavity of the form. EcoBlock's unique web system, recessed in the walls and on the outside edges of the corner block, make attaching interior and exterior finishing materials identical to working with stud construction. The webs are located on 8-inch centers and run the full height of the block. They can be quickly located by spotting the large groove on the top edge. Interior wallboard and paneling mount just like always. Most builders prefer using screws or foam-compatible adhesive or a combination of both. If you use nails, use ring shank nails for a good grip. Where wall cabinets will be set, it's easier on the installers if you mount plywood instead of wallboard. Cut the plywood to be a bit smaller than the cabinet and screw at close intervals. Heavy fixtures like wall-mounted sinks can be securely fastened by removing the foam and mounting pressure-treated lumber. The lumber is screwed directly to the concrete core using Tapcons. Exterior finishing materials, whether paneling, vinyl, or lap siding, attach just as easily. The special webs on the outside of the corner block mean that you can set fasteners right up to the edge. Again, if you choose to nail, use ring shank nails for a good grip. EcoBlock's foam is compatible with either cement or acrylic-based stucco finishes. Some systems use a fiberglass mesh, and others can be directly applied to the wall. Below grade, a damp-proofing or waterproofing system is recommended, just like you would use with a conventional basement. Make sure that any products, whether spray, roll-on, or self-adhesive, are EPS foam compatible. Be sure to check with your supplier about any required protection from backfill. Some systems can be easily damaged. One of the questions often asked about ICF construction is, what do you do if someone changes their mind, or maybe there's a mistake? The answer is simple. Concrete can be cut and drilled just like any other material. The owner of this home decided that they would like a window to be a little bit lower so they could enjoy the view. It only takes a couple of minutes with a concrete saw, and the window is lower.